Hey everyone, and welcome into Weather Classroom. I'm Meteorologist Thomas Patrick, back after a week off last week because of all the hectic air quality issues that we had back here this week. And actually, today's topic is going to be on the air quality and the hazardous air quality that we had last week and the challenges that go into measuring, reporting that, as well as forecasting it, because it's not something that is commonly predicted across the US. In fact, it's kind of exclusively a West Coast thing, but there are some really cool research tools that are being integrated right now into some of our computer models to help us predict when the air quality and when the wildfire smoke gets as bad as it did at the beginning of this month. Weather Classrooms every Thursday at 1 o'clock here on my Facebook channel, which is of course at Meteorologist Thomas Patrick. You can also watch it live on replay there, or as well as on the KREM 2 YouTube page as well. As always, appreciate everybody coming on in. Please make sure to hit like if you do love these weather classrooms, because I gotta admit, I kind of missed doing one last week, but let's catch right back up and kind of dive into some of the data and statistics that go into air quality measuring, reporting, and forecasting for today. And of course, if you have any questions here in Weather Classroom, make sure to shout them out. Just leave me a question in the comments below, and I'll be sure to answer a couple of them throughout the course of this broadcast. So let's jump into things here in Weather Classroom. All right, so first, let's go into the reporting and measuring, because it's not something that is done everywhere. It's not as common as, say, a temperature reading or a wind reading. It's not like you can just stick an anemometer outside and you got a wind measurement. It's a bit more complicated, and it's done by the Spokane Regional Clean Air Agency in town. And they actually have 6 sites in town that help to measure different kinds of air pollution and the air quality. So this was actually in a map example from, I believe, 9 days ago, last Tuesday. And you can see where the highest air quality, the highest AQI, is in that maroon shaded color. But there are 4 sites in town that measure what's called PM 2.5, and I'm going to get into the different types of air pollution recording there. 4 of them measure PM 2.5, the other 2 measure PM 10 as well as ozone, and so those 3 is what goes into our air quality index. And there's obviously going to be variations from site to site. So essentially what happens is we take whichever site is reporting the highest AQI or the worst air quality, and that's what's getting reported. But it's actually not just a measurement, it's also a 1-hour forecast as well. So it's kind of a mix mash of both a measurement and a 1-hour forecast, or sometimes we call that nowcasting, to help us kind of gauge and predict what's going to happen over the next 60 minutes. So the numbers that we see in the AQI on an hourly basis isn't always exactly what's measured. Instead, it's analyzed a month later. But as for what goes into the air quality index, or the AQI, it's 3 different types of air pollution. Starting from the largest particles, PM10, that's basically your dust, your pollen, sandstorms, dust storms, things, and mold and things like that. So those are the large particles. Like if you think of like kicking up dust on a dirt road in your car, that but on a more widespread scale would be our PM10 drops in air quality. But PM 2.5 ends up being the most important for us because that goes to wildfire smoke. It's also the emissions from like wood stoves, and that's why sometimes in the wintertime when we have stagnant air, we get reductions in air quality, because all of that, wood fire stoves, the emissions from that can get trapped in the atmosphere. But wildfire smoke is always the biggest contributor there. So when we look at that kind of air quality, when we have wildfires in the area like we did last week and the week before, it always comes down to the PM 2.5, or fine particles. By the way, 2.5 is 2.5 nanometers in diameter, and that's about 400 times thinner than a single strand of hair on your head. So obviously very fine particles that obviously if you're breathing that in can get into your lungs and kind of do some damage that way. And that's why we get air quality concerns. The final is ozone, or O3. Obviously, no, O2, oxygen, is what we need to breathe, but O3 is usually a stratosphere thing. It helps to block some solar radiation, but it's not as beneficial for us to breathe. We can't process ozone O3 as well as we can just pure oxygen, or O2, and that's like emissions, like car emissions and whatnot, produce ozone as well as carbon dioxide, as you might know. So these are the 3 different types of air pollution, and it is all measured by different sites from Spokane Regional Clean Air Agency. And I like to show you the example of what that looks like right now. So I had the example from a couple weeks ago, and here's the site right now. So obviously we're probably familiar with seeing this page on the news before, especially when it's down into these lower categories. Right now it's good, as we might expect. We actually just had some rain last night and some new fresh air coming in, so it's great. It's good. It's at 31. And here are the 6 different sites in town. So it looks like the one that's reporting the highest is actually Ozone right now, the O3. And that's way up towards the like that Colbert Airport area. So that's one of the sites. Now, these other 4 sites that are kind of closer to town, these are the ones that are measuring PM 2.5 or fine particles, the wildfire smoke. This one, kind of in the Northtown area, was always reporting the highest air quality all of last week. Today, since it's only measuring PM 2.5, 10, even better than the Ozone reading of 31. And there's also one down here in the Turnbull National Wildlife Refuge, close to Cheney. So it's these 6 sites together, and we take whichever one's the highest. That's the one that's getting reported. And by the way, remember, it's a measurement and also kind of like a 1-hour forecast that goes into this. And I say that because each month, Spokane Regional Clean Air Agency ends up publishing the reports, just the raw measurements, not the forecast anymore. And that goes into publications like this. In fact, this is from just last month, August, where, we were all like, wow, air quality's been good pretty much every single day. And there it is. In fact, it's only been in the moderate, maybe 1, 2, 3, 4, 5 out of the 30 days. We're in the moderate category and not very deep into that category. So, hey, all's good there. And if we look at August from last year, we can see the higher measurements that were published, especially when we had the wildfire smoke from the William Flats fire. Had to remember the name of that one. But only 2 days were in the unhealthy for sensitive groups. I'm very curious to see how this September is going to look, especially with just how thick and blanketed the smoke was, if we do end up having outright hazardous air quality, because that was in the Nowcast reporting for, I believe, 3 of those 7 days. But it'll be very interesting to see what the official report says come next month. So we'll still have to wait for that kind of publication. So that's measuring and reporting air quality. And there are other sites across the inland Northwest. There's also a ton of sites in California, and there's some other resources that I could show you as well. And they kind of a mishmash of precision and accuracy and whatnot. But that's definitely our most reliable source in town. But then here comes the tough part, especially for meteorologists like myself, is how do we forecast wildfire smoke? Because it's something that we don't deal with year round. It's something that most of the country doesn't deal with at all. But luckily, there's one computer model that's accessible to us that has this experimental feature that includes active wildfires and just how much smoke they're pluming into the atmosphere at any given moment. And that's the HRRR, or the High Resolution Rapid Refresh. It's a short-term computer model that usually only forecasts between 12 and 48 hours in advance. So every 6 hours, we get a 2-day forecast in terms of the smoke modeling. And this was, again, an example from last week of just how the smoke was traveling not just in the West Coast, but across the entire northern U.S. So even areas like New England were getting hazy skies from the wildfires that were in California and Oregon, and of course here in Washington as well. It's very interesting. I actually want to show you the raw data of this right now, because I believe it uses the InsaWeb as a source for where the active wildfires are, and it actually integrates it into this model to basically say, okay, how much smoke is there in the atmosphere right now, and let's add the new smoke coming in from the new wildfires, or the active wildfires, I should say. And that's not the easiest thing to add into a very complex computer model. In fact, most computer models don't even take into consideration this at all. In fact, I can say this: if you have, your phone, and if you're somebody like me that might even just, peek at the temperatures every once in a while, the default app that's on your phone, and I'm going to pull this up. I can't even find it because I buried it so far. Okay, here we go. So obviously, you have your default app on your phone and it just, it spits out the numbers. No one's actually forecasting that. No one's doing their own hand analysis. It's just a computer model spitting out all these numbers. But the computer model that does this actually does not take into consideration wildfire smoke. And I noticed this because I was actually comparing what this model that just goes straight to your phone was saying temperature-wise, and it was showing highs in the 90s last week. And I was like, yeah, that's not going to happen if there's so much wildfire smoke. So how do we get this to include? And thankfully, we have this model to help us analyze. So I'm actually going to pull up some of the raw data. So this is actually the current forecast, and I find this so interesting that if you look at the West Coast, you can specifically see where the active fires are still producing the smoke and the haze, especially in Northern California. Looks like there's some lingering kind of in the those valley areas, and the smoke that's in Nevada as well. So yeah, I find this really interesting that it's still picking up on these fires. Looks like there's one in Idaho as well. But last week it was all in Oregon and Washington, all the fires that ignited, especially from Labor Day weekend. That was included in this computer model. Now this model there's a couple different versions. This is the near surface smoke, so I was using this a lot for our air quality to show when it was going to be in the unhealthy range and the hazardous range. But there's also the vertically integrated smoke, which is essentially how much smoke is there in the entire atmosphere. And notice how, yeah, you can still see the fires, especially in California, but notice that, like, Great Lakes area in the Midwest, there's some orange here. This is mostly in the upper atmosphere. The jet stream is picking up the wildfire smoke and then pushing it along towards the eastern US. So they're not getting air quality concerns, but they're getting hazy and smoky skies as a result. So these are kind of the two main models. So there's the near surface smoke for air quality, and then there's vertically integrated smoke for haziness and smokiness overall. And it's so great to have this kind of tool. It is still experimental, so it's not perfect. We have to kind of take it with a grain of salt, but it worked really well to help meteorologists like myself use these tools, analyze them, and then put that into our forecast to say, hey, it's not going to be 90 because it's just going to be overcast smoke all day long. And it makes a big difference when it comes to forecasting. So another reason why, the app, the weather app on your phone is okay, but sometimes it doesn't have the, the hand taken care into your local forecast to say, a meteorologist like myself is doing for everybody. So that's kind of my 2 cents there. So that kind of covers it. That covers where we get the air quality measurements and reportings to begin with from, at least in our town, Spokane Regional Clean Air Agency, and how we get some forecast assistance when it comes to, because it's hard to keep track of all the wildfires across the western U.S. And this really helps, and it did a fantastic job for us last week to help us know when that smoke was coming in, when the air quality was going to drop, and when it was going to leave. And it was like basically 7 straight days in Spokane. So to recap here on Weather Classroom, the air quality is measured in 3 different ways. There's the PM10, which are large particles. That's dust, and that's like dust and mold, dust storms. That would be PM10. PM2.5 is fine particles, so that's your wildfire smoke, and ozone, or O3, which tends to be stagnant air that is sinking down towards the surface, and it makes it a little bit more difficult to breathe. The reporting site in Spokane is an hourly nowcast, so it's both a measurement and a 1-hour prediction, and they actually analyze and publish their reports the month later. And very few weather models actually take into consideration wildfire smoke and air quality in its forecasting. So a lot of times the raw data that might be going to your cell phone at home might not be representative of what the actual forecast is. So just, again, my 2 cents is why a meteorologist is always just a little bit better, or sometimes a lot better than just what your phone is going to say. So hopefully with that, I can prove that I'm still a very trustworthy source. I think we got it right on the nose when it came to when that air quality was coming in and coming out. Big thanks to those computer models that were helping to guide us, but we still had to hand analysis all of that information, which is no small feat to begin with. So with that being said, that's it for today's Weather Classroom. I'm very much glad that we're back into the good air quality here in Washington. And thankfully, with the rain and the system moving through, I think that's a good season-ending event. So we should not have to worry about any kind of air quality concerns, or hopefully not wildfire smoke for the rest of the month and heading into the fall season, of course. With that being said, again, if you have any questions about this topic or even a future weather topic that you'd like me to dive into and explain in great detail, do make sure to leave me a comment below here on Facebook or on YouTube as well. I make sure to read all those comments. But again, thanks again for being here. I think these are really fun and very educational, and hopefully these are fun and educational for you as well. So please make sure to hit like on this video as well as on my Facebook page as well. I'm Meteorologist Thomas Patrick. That's where you can find me on Facebook and Twitter. If you do like me on Facebook, you will get push notifications for when I go live, so you can join us live and ask those questions. But other than that, I got nothing else. So with that being said, thanks again, everybody, for tuning in to today's Weather Classroom. Back next week, 1 p.m. Pacific time on my Facebook channel, Meteorologist Thomas Patrick. We'll see you there for another Weather Classroom. Until then, have a great day, everyone, and we'll see you next time.